Hey friends, so this video is going to be on solving non-polynomial equations. And they're non-polynomial because their powers are not whole numbers. But a lot of the things we do is similar. So if we look at number one, I think that the way you want to approach these is you definitely want to look to see how many times, first of all, how many times does the variable x show up? And it's only there once. So then the goal is to get it so that it is x to the first. So your goal is to get x equals. Well, we never really talk about this, but x equals really means x to the first power equals. So our problem with this is that you have a power that's not 1. X has a power that's not 1. X has a power that is 3/5. So the way we get rid of that, we talked about in our last class, is the way we get rid of that is we are going to take this side of the problem and we are going to raise it to the power of 5/3. And we learned, the very first day in algebra probably, that what you do to one side of the problem, you have to do to the other side of the problem. So if you if you raise the power of 5/3 on the left, you have to do it on the right. And the reason you do that is because this 5 will cancel out this 5, and this 3 will cancel out this 3, and so you're left with x. Over here, what you really, and you can type this, if you don't want to do, and I'm never an advocate for not thinking, but if you don't want to think, you literally can put this in your graphing calculator, just like it is, and hit enter, and it will give you the answer. What it actually means, if we want to talk about what it means the third root of 27 raised to the power of 5. And the third root of 27 is 3. And the third root of 27 is 3 because 3 times 3 times 3 is 27. And then that is going to get raised to the 5th power. And so I think that is 243. So I think this comes out to be 243 because 3 times 3 times 3 times 3 times 3, this is 9, and this is 9, and this is 81, and 81 times 3 is 243. But if you don't want to do that, you can just put it in the calculator. You can go and you can grab your calculator, and you can wait patiently for your calculator to open. And what was it? I think it was 5/3. So if you grab your calculator and you input 27, and it doesn't matter on this one, but it's probably a good idea to put it in parentheses because if it was a negative number, you would need the parentheses. You'd take 27 and you would, not yet. You would take 27. And first of all, you would raise it to a power. Then you turn the power into a fraction. And I think the fraction was 5/3. Is that what the fraction was? And then you'd hit enter. And you get 243. So you get 243. So that's your answer. Okay, so if we look at number 2. Again, my suggestion is, the very first thing is you should look to see where the variable x is and how many variables of x you have. And x is only appearing once. X is right there. So our goal is to get x to the first power equals blank. That's our goal. So we're going to move the 10. So that would be a 64. Then we're going to divide by 2. And that would be a 32. And then we're going to use the reciprocal power. So If this is 5/4, we need 4/5. And if you do it on one side, you do it on the other. And so this answer comes out to be 16. Now, it's 16 because you can put it in the calculator, or it's 16 because you have the 5th root of 32. And then that is being taken to the 4th power. Well, the 5th root, so 32 broken down into prime factors. That's 2, 4, 8, 16, 32. So 2 to the 5th power is equal to 32. So the 5th root of 32 is equal to 2. And then it's supposed to be raised to the 4th power, and 2 times 2 times 2 times 2 is 4 times 4, which is 16. Or you can put it in your calculator. 32 raised to the power of 4/5, enter is 16, and just have no interest in knowing why, but that's why. Okay, so if we look at this one, again, if we study, we only have, I love it when it thinks for me. We have that, but the very first thing that has to happen is the power needs to go away because the x is being multiplied by 2, which is being subtracted by 3, but all of it is inside the parenthesis. So we have to get rid of the parenthesis. And the way we're going to get rid of the parenthesis is we are going to multiply this side of the problem by 7/9. And we're going to raise, I should say raise is better than multiply, that to 7/9. And if you get that, then you have 2x minus 3 is equal to -1. If you're unsure that that's -1, again, and I'm going to do this on the calculator just because I want you to see that it is important to have the, it wouldn't matter in this one either, but it's important to have the parentheses. So if you had parentheses, -1, close it, raise it to a, what was it, 7/9? 7/9. And hit enter, you get -1. By the way, if it wasn't 7/9, if it happened to be 9/7, it wouldn't matter because 1 is a unique, 1 has some unique qualities that other numbers do not have, but we're still going to get -1 regardless of the way we put it in. So just because that's the nature of the number 1. So we have that, and then we just solve the problem. I mean, from here, it's basic pre-algebra problem. I mean, we say that, 2x is equal to 2, so x is equal to 1. So what looked horrible, not horrible at all. And it was 7/9. Okay. So now when we look, we notice that we have x here and we have x here. We notice that we have a trinomial. We notice that the power of this x is twice as big as the power of that x. So in our mind, we think of factoring. And so then we think to ourselves, is there any factor of -10 that adds to 3? And the answer to that is yes, 5 and -2. So we are going to say that we have x to the 1/3 power x to the 1/3 power plus 5 and x to the 1/3 power minus 2 is equal to 0. And if you're uncertain, you multiply it back together, and yes, you get what we started with. Then you take this factor and set it equal to 0, and you take this factor and you set it equal to 0, and that will get you x to the 1/3 power equals -5. And this gets you x to the 1/3 power equals 2. Then you need to get rid of the 1/3 power, which means you need to cube this. And -5 times -5 times -5 is -125. And 2 times 2 times 2 is 8. So you would say in Canvas your answer is -125 and 8. So it's just like factoring quadratics, but they're not quadratics anymore. But it's still a trinomial. And the middle term's power is half as much as the first term's power, so it should be factorable. All right, so if we look at this, this is just like the last one. We notice we have x here and we have x here. We know that this power is twice as big as this power. And so we should be able to factor it. So we're going to say, and I'm going to do it by guess and check, because 2 is prime and 1, factorization of 1 is 1. The only thing I have to decide is where the positive and the negative go. And I want a negative middle. So if I want a negative middle, this is going to have to be negative and this is going to have to be positive. And that's a lot faster than splitting the middle term, friends. So then you say 2x to the quarter is equal to -1. And here you say x to the quarter is equal to 1. And then you're going to divide this one by 2. And that's going to give you x to the quarter is equal to -1/2. And then I would take this to the power of 4, and I would take this to the power of 4, and I would take this to the power of 4, and I would take this to the power of 4. And this will get you x equals an 8 to 4, 8 16, I'm sorry, a 16th. And this will get you 1 times 1 times 1 times 1 is 1. And the 16th is positive because of the sign. And so that's a perfect example of showing you why the parentheses are important. If you take negative, I haven't done this before, so let's see, 1/2, and you raise it to the 4th power. Yeah, see, that's wrong. If you open a parenthesis and take negative 1/2 and put your power outside, then you get the right answer. So the parentheses are important. The problem is the parentheses are important sometimes and not other times. So I always put the parentheses in. That way I don't have to think about will it matter or not. Again, not recommending not thinking, but it is what it is. All right, and last but not least, so I would rewrite this as 3x to the power of 2/3 minus 8x to the power of 1/3 minus 3 is equal to 0. And again, I would notice that I have a power of x here, or a variable x here, and a variable of x here, and this power is twice as big as that power, so I can factor this as normal. And because 3 is prime, I am going to do guess and check. So I'm going to go 3x to the 3rd and x to the 3rd. And the factors of -3 are 3 and 1, but I need -8, so the -3 is going to have to go here. You know, or you can split the middle. Split the middle like you always split the middle, factors of -9 that add to -8, and do all that. But this is faster. It's not a race, though. Get it right. 3x to the 1/3 equals -1. x to the 1/3 equals 3. Here, because x isn't isolated yet, we need to divide by 3. So I guess I could have written that. We need to divide by 3. So we have x to the 3rd equals negative 1/3. Not that that's not too many 3's. Then we're going to take this to the power 3. We're going to wrap this in parentheses to the power 3. We're going to wrap this in parentheses to the power 3. We're going to wrap this in parentheses to the power 3. And that's going to give us x equals a negative 1 over 27. And this is going to give us x equals 27. All right, my friends. You know what? Yeah, there you go. That's it. Have a great day. If you have any questions, ask me in class or send me an email. Thanks, guys. And turn